Hello everybody, this is Matt IV, and today we're going to be attacking the 2024 AMC8 p25. The question reads, a small airplane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability that there will be 2 adjacent seats in the same row for the couple? So the problem gives us 4 rows, 3 seats in each row. Immediately, we should draw that. So 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3. All right. Now, 8 passengers have boarded the plane already and are distributed randomly. So in total, there are 4 rows with 3 seats in each row. So there are 4 times 3 equals 12 seats total. We subtract that by 8 because 8 have already boarded, which leaves 4 empty seats. And now a married couple is next to board. What's the probability that there will be 2 adjacent seats? So you want the probability of 2 adjacent seats among the 4 empty seats. So this is a very, very standard probability problem. In probability, what you always want to do is number of desired outcomes divided by number of total outcomes. And this is like how you approach all probability problems. You have to do it like this. Number of desired divided by number of total. And we're going to have to calculate each one of these, number of desired and number of total, to be able to get our answer. So first, let's start with number of total. There are 4 empty seats among 12. So there are 12 seats to choose from. You want to choose 4. So that's equal to 12 combination 4. And for those of you who don't know combination, the formula is equal to if A choose B equals A factorial over A minus B factorial, B factorial. And I highly recommend you read more about this. This is a very important formula that you have to understand why it works and its applications. So I highly recommend you, if you don't know already, make sure to research on combinations. So we're going to be using combinations a lot in this problem. So first, we have 12 choose 4, right? There's 12 people, you're going to choose 4. So to do this, what we do is we apply the formula. So 12 factorial over 4 factorial, 8 factorial. That's equal to 12 times 11 times 10 times 9 times 8 factorial over 4 factorial, 8 factorial. And we can cancel this out, and we can simplify. And this becomes 495. So immediately we have the number of total outcomes is 495. That's great. We have our denominator. So 495 is our denominator. All right, cool. So now we got to find the number of desired outcomes. And the number of desired outcomes is the number of cases where among the 4 empty seats, there are 2 adjacent seats. So this is a very clear indication of casework because there are many different ways to have 2 adjacent seats. And we have to do casework on each one of them. And whenever we make our cases, we have to be extremely careful to not repeat any cases because repeating cases will result in a lot of overcounting. We have to subtract. It gets very complicated. So let's do some straightforward casework. Case 1 is when there are only 1 pair of adjacent seats. Okay, 1 pair of adjacent seats, and they're separate. So that means that when there are only 1 pair, let's say this pair is the adjacent seats, then when they're separate, that means that the other 2 are among these, where that's like these. This is an example of case 1. Notice in case 1, I'm not including the case where a person's in this row right here, the same row as the adjacent pair, because that is another case where it's going to be different calculations. And I'll explain more on this later. But first, let's do the case 1 pair of adjacent seats separate. So first of all, let's calculate the number of ways to make a pair of adjacent seats. So using a different color, we see 1, 2, 3, 4, 5, 6, 7, 8. So let me draw this circle like that. 8. So there are 8 ways, 8 ways to make a pair of adjacent seats. Now we have to find the number of ways to seat the other 2 empty seats, right? There are 4 empty seats total. We've already sat 2 of them. Now the other one, for the other 2 empty seats, there are 9 seats to choose from, right? Because remember, we're leaving this row alone, right? Because the row with the pair already, we're leaving it alone. There are 9 remaining seats, and we got to multiply that. 9 choose 2, because again, there are 9 seats. We want to choose 2 empty seats from it. So we do 9, choose 2. Subtracted by the number of ways where they are adjacent, right? So let me redraw this. This is getting a little bit crowded. So basically, we have to subtract the cases where of those 2 empty seats you choose here, they're adjacent. Because remember, we want them to be separate, as we're only calculating the case of 1 pair of adjacent seats. So we chose 2 from the 9, and we get to subtract 1, 2, 3, 4, 5, 6. We have to subtract 6 cases from that 9 choose 2, because in those 6 cases, that will result in 2 pairs of adjacent seats, which is not what our case is. So now we can do 8 times 9 choose 2, which is 36, right? Remember, 9 times 8 over 2, minus 6. So 36 minus 6. And that gives you 240. So case 1 is 240. So remember, this is the total. And then for the desired, let's write that here. Desired is 240 plus. All right. So we've done our case 1, 240. Now we have to do case 2. And case 2 is going to be that case I was talking about earlier, where there's still only 1 pair of adjacent seats, right? So there's only 1 pair of adjacent seats, but instead of like the extra row up there being empty, it's gonna be filled with an empty seat. This is what I mean. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So again, let's say again that these are the 2 empty seats for the couple, right? These are the 4 out of 4 empty seats. We choose these 2 to be for the couple, right? So now case 2 is 1 pair of adjacent, and like the row, there's like a total open row. So what I mean by open row is that the whole row is empty. So with that being said, first we have to find which row is empty, right? So there are 4 rows. You need to choose 1 row to be empty. So that's 4 cases, 4 different ways to choose the row. Let's say we choose the top row. If we choose the top row, then that means that for here, the top row is completely open. So that means that there will be 2 adjacent seats guaranteed in that row. So therefore, we don't need to multiply by anything because, again, as I said, this whole row is empty. So we don't need to like find the number of ways to seat the 2 people in the row because they can sit anywhere they want, right? There's going to be 2 adjacent seats for sure. Now, out of the remaining 9, we got to seat 1 more empty seat. So that's 36. Remember, there are 4 empty seats total. We've already selected 3 of them because it's open row. And now we have to choose the other remaining seat. And again, this is going to cause a married couple to have 2 adjacent seats on the same row. All right, so 240 plus 36. And now for our last case, it's probably the most intuitive case, is case 3, 2 pairs of adjacent seats. So let me just do that real quick. Case 3, 2 pairs of adjacent seats. And there are 2 pairs of adjacent seats. What does this mean? Well, thankfully, there are only 3 seats in each row. So therefore, it makes our life a lot easier when doing this casework because we know that guaranteed these 2 pairs of adjacent seats have to be on different rows. Because again, each row can only seat a max 1 pair. So what do we do? Well, we first have to choose the 2 rows to have the pairs, right? So there are 4 rows total. After that, we need to choose 2 of these rows to have the pair of adjacent seats. Now, let's say we chose this row and this row, just without loss of generality, right? So now we have to find the number of ways to seat the pairs, right? To have the empty seats. So the empty seats can either be this or that, right? It can't be these 2 because it won't be adjacent anymore. So for each row, there are 2 ways to seat the pair of empty seats. And remember, the seats have to be adjacent. That's why there's only 2 ways. So now, in total, that's 24. All right. So now we have our total number of cases, and we have the number of total outcomes and number of desired outcomes. So therefore, we can just divide them to get our answer. And we know that we're done with all cases because we've done 2 pairs, right? 2 pairs of adjacent seats. Because remember, there are only 4 empty seats total. So there can either be 2 pairs or 1 pairs, right? And because we've done the 2 pairs already, and the 1 pair we've already done the 2 cases where open row or non-open row, we can be confident that none of the cases actually overlap. And we've covered all the cases. So we can just find our answer now. 240 plus 36 plus 24 is equal to 300. So we have 300 over 405. And we can simplify this further. Divide both sides by 5 equals 60 over 99. Divide both sides by 3. So our answer is 20 over 33. Hope you guys enjoyed this video. May the force be with you all. Thank you for watching.